All right, we're going to take a look at finding the increasing and decreasing intervals and being able to write those open intervals, primarily by looking at our derivatives. So I have the graph over here to the bottom right so that we can use to pretty much compare. We'll know what our expectation is going to be in terms of when this graph is increasing, decreasing, we'll take a look at how we can find all of that information from finding the derivative. So first thing we need to do, just like you did before, in the lesson before, is find our critical numbers, right? We need to find those critical values. So our first step is to find our critical values. In order to do that, what we need to do is we need to find our derivative. So we need to find f prime of x. In this case, f prime of x is 3x squared minus, now that 2 drops to the front and we multiply, and 2 times 3 halves, we end up with just a 3, and then an x to the first power. To find those critical points, those critical numbers, what we need to do is set this equal to 0. So we set it equal to 0 and we could factor. We'll factor out a 3x, and then we have an x minus 1 left over. So we have two critical values. We have a critical value at x equals 0 and x equals positive 1. Now, to determine whether graphs are positive or negative, right, what we're really concerned about is what is the slope doing at these points. So what we're going to do is we're going to take a look at a number line, and we're going to focus in on these critical numbers. Right? So we'll plot these critical numbers in on a number line. So I have a 0 and I have a 1. And what we're going to do is we're going to find test points that are not at the critical values. So we're going to find a test point to the left of our first critical value. So I'm going to pick -1. We're going to have to find a test point in between our two critical values. So in this case, I'm going to pick 1/2. And we need to find a test point that's after that. So any number is fine as long as it meets those conditions, to the left, to the right, and in between if we have more than one critical value. So the next thing we're going to do is we're going to need to test these critical points with our derivative. So we're going to need to find, okay, what is f prime at -1? And really what we'll do is we'll just substitute in here. We'll have 3 times -1 squared minus 3 times -1. And when we evaluate that, we have f prime at -1. We have 3, and then minus 3 times -1 is really just plus 3, so we get a 6. Now what we're concerned about is knowing that in this area we got a positive value. It doesn't really matter what the number is. In this case, we just want to know if it's positive or negative. And then we're going to continue and we're going to find the value of our next test point here. So I'm going to find, in this case, f at 1/2. Now you guys can use f prime at 1/2. You guys can use the calculator to help you out here. I'm just doing these by hand. So we have 3 times 1/2 squared minus 3 times 1/2. And when we evaluate this, we have f prime at 1/2. We have 3 times 1/4 minus 3 times 1/2, or 3/2. So we have f prime at 1/2 is equal to 3/4 minus 3/2. And when we subtract these, we're going to end up with a negative value. So we're going to end up with -3/4. Okay, and again, we don't necessarily care what the number is, but what we do care about is that it's negative. And then we got to do the same thing with our final point here. I ran out of a little space, so I'm going to just reposition here. We're going to have to test this f prime at 2. So we're going to end up with 3 times 2 squared minus 3 times 2. And then we have f prime at 2 is equal to 3 times 4 minus 6. F prime at 2 is equal to 12 minus 6, which is 6. And in this case, that's a positive value. So what our concern is increasing, decreasing. If we know the slope, which is the derivative, is positive, we know the graph is increasing. When it's negative, we know this graph is decreasing. And again, so what's happening is our graph at this point in time is increasing. then all of a sudden it's decreasing, and then it goes back to an increasing graph. So we're going to write our interval on when this function is increasing versus decreasing. So our increasing interval is going to be from negative infinity, right? All those values to the left until that critical point where it goes from positive to negative. So from negative infinity to 0. And then we have another increasing interval from our second critical point, 1 to positive infinity. Since there's no more critical points, it's growing without bounds. It just continues up. Now, when we take a look at our decreasing, we know that this graph has a decreasing interval between those two critical points, so between 0 and 1. Now, we write open intervals because those are not including. It's 0 at 0 and 1, right? The slope is not increasing or decreasing, so we can't say that the graph is increasing or decreasing itself. Now, if you guys compare this to the graph, we get a pretty good look, a pretty good view of what's actually going on here. We see the graph is increasing until we get to the point 0. Then we start to see the graph decreasing, and then we start to see the graph increasing again. And that follows our pattern with these critical points, these critical numbers. So ultimately the goal is to find the critical numbers, the critical values, then test to see what's going on around it. Are they increasing? Are they decreasing? And again, you can use the calculator to help you out there instead of doing it by hand, but please do make sure that you guys are testing it against the derivative of that graph.